Hello students, welcome to another video of Electrostatic with me Siddharth Bhattacharjee from Parul Academy. As we have discussed in last video that to calculate the electric field due to a point charge or due to a charge distribution, we use Gauss theorem. What is Gauss law? According to the Gauss law, the total flux linked with a closed surface is 1 by epsilon times the charge enclosed by the closed surface, denoted by phi. Closed surface integration of E vector dot ds vector equal to E ds cos theta, and that is equal to Q by epsilon naught. Here theta is the angle between electric field and area vector, which is perpendicular to the plane outside. For example, a point charge Q is placed inside a cube of edge A. Now, as per Gauss law, the flux through each face of the cube is Q by 6 epsilon naught. The electric field is the basic concept of knowing about electricity. Generally, the electric field of the surface is calculated by applying Coulomb's law. But to calculate the electric field distribution in a closed surface, we need to understand the concept of Gauss law. It explains the electric charge enclosed in a closed or the electric charge present in the enclosed closed surface. The net flux through a closed surface is directly proportional to the net charge in the volume enclosed by the closed surface. In simple words, the Gauss theorem relates the flow of electric field lines, that is flux, to the charges within the enclosed surface. If no charges are enclosed by the surface, then the net flux remains zero. This means that the number of electric field lines entering the surface equal to the field lines leaving the surface. The Gauss theorem statement also gives an important corollary. The electric flux from any closed surface is only due to the source, positive charges, right, and sinks, negative charges of the electric field enclosed by the surface. Any charge outside the surface do not contribute to the electric flux. Also, only the electric charges can act as source or sink of electric fields. Charging magnetic fields, for example, cannot act as a source or sink of electric fields. The net flux for the surface on the left is non-zero as it encloses the net charges. The net flux for the surface on the right is zero since it does not encloses any charge. Note one thing, the Gauss law is only a restatement of the Coulomb's law. If we apply the Gauss theorem to a point charge enclosed by a sphere, this is known as a Gaussian sphere or Gaussian surface, we will get back Coulomb's law. Let us calculate electric field due to a point charge using Gauss theorem. Number 1, we will enclose the charge with a sphere, including the point where we have to find the field, say at r distance. So the radius of the sphere will be small r, and take a ds area on that sphere. Number 2, the ds vector and the electric field vector is on the same direction. So angle between E vector and ds vector is 0 degree. Then electric flux phi is equal to integration of E dot ds equal to E integration of ds cos 0 degree equal to Es equal to Q by epsilon naught. So E equal to Q by S into epsilon naught, as surface area of this sphere is 4 pi r square, so E equal to Q by 4 pi r square into epsilon naught. Now we will discuss about the electric field due to an infinite linear charge distribution. Let the total charge on an infinite long wire is capital Q, and we will find electric field due to the charge distribution at a distance r from the wire. We will consider a segment of length L from the wire. So linear charge density lambda equal to Q by L. Now we will enclose the wire with a Gaussian surface that is cylindrical in shape. So there will be three faces. One is upper and down surface and other is the curved surface. As electric field and area vectors are perpendicular on these surfaces, so flux through those surfaces will become zero. Means the only flux will be there due to the curved surface. Say the small area of the curved surface is ds. Then the electric field and the area vector on this surface is in the same direction and theta equal to 0 degree. So phi equal to integration of E dot ds equal to Es cos theta equal to Q by epsilon naught, as theta equal to 0. So it will become Es equal to Q by epsilon naught and E equal to Q by S epsilon naught. Now put the value of S, that is 2 pi RL, and we get E equal to Q by 2 pi RL epsilon naught. As Q equal to lambda into L, so the final value of electric field will be lambda by 2 pi R epsilon naught. Thanks for watching. We will meet in the next video with another interesting concept. Thank you.